Everyone, hope doing well. Today gonna be a revision for how to solve the SDP for section 2.11 until 2.13. This section is very important because most of the questions that come of it are math applied. Okay, but let's make a small revision. We have two types of motion. We have URM, and the second one is UARM, which is uniform accelerated rectilinear motion. For URM, we have the equation x equal to vt plus u. For URM, the equation of motion is simply x equal to half at squared plus ut plus x0. Second one is v equal to at plus u. Third one is v squared minus u squared equal to ad. Fourth one, x equal to v plus u multiplied by time over 2. Okay, there is conditions when I use these rules. I use the first rule when is no distance given, and you want to find, for example, velocity or acceleration. He will give you variables. Here, no time given. Here, no acceleration given. These rules, I have to memorize them and know how to apply them. So we're going to go to my first equation over here. First thing, I have to get the given out of the text. Let's see together. A particle initially found at 2 meters. This represents the initial position, x equal to 2. To the right of the origin, initially moving at 6 meters per second. So this represents speed. Initially and moving, that's going to represent u. The particle accelerates at a rate 4 meters per second squared. Look how much the unit, 4 meters per second squared. So that acceleration is 4 meters per second squared for 2 seconds. He wants the position x equal to after 2 seconds. He gives you the time. Okay guys, here I'm accelerating. Let's go back to my rule. I want the position given acceleration and time, initial velocity. I'm going to use my first equation. So x equal to half at squared plus ut plus x0, half multiplied by 4 multiplied by 2 squared plus 6 multiplied by 2 plus initially he was at 2. Using calculator, 8 plus 12 plus 2, my answer going to be 22 meter. Let's go to my second equation. Okay. Second equation is telling me a cyclist accelerate from rest. A cyclist accelerated from rest for u equal to 0. For how long it took him time 20 seconds at a rate of 0.4 meter per second. She then, okay, خلاص, that's my first part of the question. She then travels at a constant speed for extra how much? 60 seconds. He wants the top speed of the cyclist during the motion described. He wants the top speed. Okay, that's easy. V equal to 80 plus u. V equal to 80 plus u. So acceleration was 0.4. For how much time? He accelerated for 20 seconds, then move at rest. Then move constant for 60 seconds. So time over here, the one he speed up only 20 seconds. So multiply by 20 plus u, my answer going to be 8 meters per second. Gonna be 8. Let's go over here. I want the net displacement of the cyclist. Okay, there is an easier way to find net displacement using an area. Area under graph. Area under the graph. But first I have to draw the graph. Okay, let's go to my text. Again, a cyclist accelerated from rest for 20 seconds. That's a draw. Let's draw VT graph. That's V, that's T. Okay. So accelerate for rest for 20 seconds and I start increasing at time equal to 20. My velocity over here was 8 meters per second. Then he told me travels at a constant speed for 60 seconds. Yani for extra 60 second travels at a constant speed. Okay, the first phase finishes at equal to 20. So my new time going to be 80, which is 60 plus 20 seconds. Okay, I want the net displacement of all. Net displacement of all. Okay. This looks like what? Yes. Trapezoid. Okay, the area of a trapezoid is the small base plus big base multiplied by height divided by 2. Over here, represent the small base, gonna be 60. From here to here, represent the big base, going to be over here 80. And my height going to be over here, that's gonna be 8. So let's substitute now my values. So 60 plus 80 multiplied by 8 divided by 2. My answer going to be 560 meter. So guys, always, if you give you text, faster way, let's draw a VT graph and get the area under the graph. Let's go for my next question, same idea. A train moving along a straight track accelerated from rest at acceleration at 1 meter per second for 10 seconds. That's my first phase. It then moves at a constant speed for 10 seconds. And finally, the acceleration uniform to stop in what? 10 seconds. What the position and distance covered? Okay, let's together try to draw VT graph. If you draw a VT graph, everything solved. VT graph. Start from here, 0. Okay, a train, let's see what the first phase. A train accelerates from rest at 1 meter per second for 10 seconds. So it increases with speed. Here time was 10. Let's get the value of the velocity over here. The value of the velocity. You can do it mentally. For example, I'm accelerating 1 meter per second for every second for 10 seconds. So that's V gonna be 10. But also if you forgot, you can use the rule. 80 plus U. Acceleration 1 times 10 plus 0 give you 10. Value here is 10. Then he told you it then moves at a constant speed for extra 10 seconds. Extra 10 seconds. It was initially 10, so time over here gonna be 20. And finally, the accelerator uniform to stop in other 10 seconds. So after 10 seconds, it goes, here time gonna be 30. Here time gonna be 30 seconds. Okay, what is the position here? So position, same as displacement, represent area. Okay, this looks like what? This looks like a trapezoid. This looks, guys, like a trapezoid. So the area equal to small plus base multiplied by height divided by 2. Here the small, the parallel lines. So from 10 to 20, that's 10. This is the big base. From 0 to 30, that's 30. And if you wanted to get the height, is also 10. So now let's substitute my answers. So 10 plus 30 multiplied by 10 divided by 2. My position going to be 200 meter. And that's how you saved time during the exam. You have always to what? Always to draw the graph, then at the end, get the position. Okay, let's see what he wants over here. I have a toy car passes the origin with the speed 1.8. This present initial speed in the positive. The decelerating at a constant rate. Decelerating, it means an acceleration gonna be negative, so minus 0.5. He wants the position X for toy car 2 seconds later. 2 seconds what? Later. So time equal what? To 2. So let's get X. Okay. Since over here there is no for example like 2 phases, 3 cases. Let's go with the basic rule. X equal to half t squared plus ut plus x0. Don't forget acceleration in negative multiplied by time squared plus 1.8 multiplied by 2 plus 0 give you minus 1 plus 3.6 plus 0. My answer going to be 2.6 meter. Okay, this question over here is similar to the one above. A train moving alongside accelerated from rest So u equal to 0. 2 meters per second. Acceleration was 2 for 20 seconds. That's my first phase, first cycle. It then moves the constant speed for 2 minutes. Pay attention, 2 minutes, it should be in second. So 2 minutes represent 120 seconds. Then, and find acceleration uniform to stop in 10 seconds. What is the net displacement? Okay, let's draw a graph. VT graph. Let's start with our first phase. It ran a strong acceleration from rest at 2 meters per second. So increasing speed. It moved over here for 20 seconds. Okay, I need to get the value of the velocity. Again, V equal to 80 plus U. Acceleration was 2 multiplied by 20 plus 0 give you 40. So acceleration over here is 40. And then moves at a constant speed for 2 minutes. That's constant speed. Let's make it shorter. Okay, that's constant speed for extra 2 minutes. So 120 seconds plus 20 give me 140. And uniformly accelerate in 10 seconds. Here gonna be 150. What is the net displacement? Akid. Again, we're going to go what? Area under the graph. This looks like a trapezoid. So get area. Small plus base is multiplied by height over 2. This represents the small base, which is 140 minus 20 is going to be 120. It's going to be my long base. The height represents the maximum velocity. Let's put the numbers. So 120 plus 150 multiplied by 40 divided by 2. My answer going to be 5,400 meter. Okay. Over here, he makes it easier for you. He already gave you the graph. A car moving at a speed, even if you don't give you the graph, you have to draw it. But here, what the difference between this question and this question? All of our questions starting from rest. So velocity gonna start from here. But now a speed 4 meters per second. Yani this is gonna be my U. So the graph is gonna be like a little bit lifted in the beginning. If he doesn't give the graph, but he make it easier for you over here, he give you already the graph. The accelerator then move at a constant speed, final product accelerating and uniformly the motion summarized by this velocity graph. The area under the graph at between time equals 0 and time equal to 3. The time equal to 0 and time equal to 3. Okay guys, this looks like a flip trapezoid. Again, this looks like what? Flipped trapezoid. So this is gonna be my small base. Here gonna be my big base, and my height going to be now horizontal, not vertical as always. My height going to be 3. So part A is telling me getting the area under the graph. So 4 plus 10 multiplied by 3 divided by 2 give you 21. Let's go to my second graph, second part. Distance covered during the first 2 seconds. Okay, asking for the distance. It's the same thing, also area under the graph. Since displacement and distance, if they're moving straight line, going to be the same. But here it means like use the rule. 80 squared plus ut plus x0. Okay, in bubble question, directly faster for you, directly going to be the area under the graph. But for written, you have to read the steps. So half 2 3 squared plus 4 multiplied by 3 plus 0. 9 plus 12 give you also 21 meter. Okay, someone gonna tell me, Mr. From where we get this value of the second one? Let's go to my text. A car moving speed 4 meter per that's U. Accelerates 40 meters per second for 3 seconds. That's going to be my given. Okay, let's go over here. Where the velocity time graph shows a car starting from rest, accelerating for 5 seconds at the rate 4 meters per second squared. The car moves at a constant speed for 4 seconds. At which interval does this formula works? This formula works only between 0 and here. Let's do the graph. From 0 to 5 seconds. But why? As you can see over here, guys, the original equation x equal to a t squared plus ut plus x0. Only here I have half a t squared. Okay, it means that u is 0 and x0 is 0 also. So I use this when I'm accelerating from rest. Accelerating from rest. At what interval this works? This works for URM motion when speed is constant. Speed is constant, and of course if you're moving in the same direction, speed and velocity magnitude are the same. So between what time and what time my graph was horizontal? Between 5 and 9. So between 5 and 9 seconds. Okay, total distance in the first 9. Again, guys, one distance give you graph, gonna be area under my graph. Okay, from 0 to 9. My height was maximum velocity, that's 20. Small base was 9 minus 5 give you 4. Big base from 0 to 9, and just apply the rule. So 4 plus 9 multiplied by 20 divided by 2 give you 130 meter. Let's go to the second part. It told you the velocity of the car at what time? 3 seconds. And time also what? 7 seconds. Graphically, let's go. At v equal to 3, when time was, let's now remove this. I don't need them, just to have a clear reading of the graph. A time equal to 3 seconds over here. Time equal to 3 seconds. Gonna be nearly 12. Okay? But over here, what happens if you don't know how to read the graph, or the graph not really clear? Let's apply the rule. V equal to AT plus U. Acceleration from the text, acceleration was 4. U was 0. So V equal to 4 multiplied by 3 plus 0 give you 12 meter per second. At time equal to 7 seconds, this is at t equal to 3, at time equal to 7 seconds. Let's go for graphically, since the velocity is constant, read from the graph, my velocity going to be 20. Let's go to third part. The highest velocity of the car in kilometer per hour. My graph unit is meter per second. My highest was 20. So let's convert just 20 meter per second to kilometer per hour. And multiplied by 3.6. My answer going to be 72 kilometer per hour. In this question, he's giving you a text and he give you 5 options of graphs. Okay, which one I should choose? Which one going to be correct one? Same, guys. I have to read the text and convert the text into what? Into a graph. Let's read it. A car decelerates uniformly from speed 40 to speed what? 10 for the first 5 seconds. Decelerating, يعني my graph going to start from what? From maximum goes to what? To minimum. Okay, here I'm increasing, no. Here I'm increasing, no. Here I'm constant, no. Here's I'm constant, no. So I'm decelerating gonna be over here. This is going to be the correct one. Then it stops accelerating and moves with constant velocity. So decelerating, then goes constant for the next, and finally start accelerating. It reaches 4 meters per second, start going up. So this is going to be my correct answer. Let's go to my final question. A car initially moving at 0.8 meter per second represent initial speed 0.8 meter per second in the positive direction, accelerating at the rate 0.1. Acceleration is what? 0.1. The magnitude of a velocity of the car 3 seconds later. So time is what? 3 seconds. So notice in given I want velocity, my only rule V equal to AT plus U. 0.1 multiplied by 3 plus 0.8 give you 0.3 plus 0.8 give you 1.1 meter per second. Okay guys, this is my worksheet. I hope you watch the video once or twice to get it, then go and practice by yourself and try to draw the graph and pay attention for the time management. Yeah. Try to understand the question and also be good at time so you can do one of the MCQ, and good luck.